So today, starting off in the introduction to our limits, what is a limit? You guys have heard limits before, right? Speed limits, spending limits, budget limits.
What's the maximum? Yeah, the maximum.
So like if the speed limit is 55, says I can approach it without going past it, or a budget limit, right? I could spend X amount of dollars as I approach it. You can sort of think about the same way with definition of a limit in mathematics. So here, if f of x becomes arbitrarily close, to a unique number, which we'll call capital L, as x approaches some number c from both sides, we then say f of x, the limit of f of x as x approaches c is L. And this is written as again, the limit of f of x as x approaches c is equal to L when this condition happens. This has no relevance whatsoever on what f of c is. F of c can be defined, it doesn't have to be defined. F of c can be a total different number other than L. A limit just says, what is f of x, the value of f of x, as I get closer and closer to x equaling c. So, we can use a table to estimate the limit. So here we want to find the limit of f of x minus, excuse me, of 5x minus 3 as x approaches 3. So, construct a table and take a look at those values right around it. So here I have 2.9. What do I get when I evaluate this at 2.9? All right. 11.5. What about 2.99? 11.95 and 2.999.
11.995.
And let's assume we don't know the limit as x approaches 3. We don't know what that value of 3 is, but what about 3.001? I'm sorry?
12.005.
12.005, all right. 3.01.
12.05.
I know other people know how to do this other than me. And lastly, for 3.1. I'm sorry? So by, what's that? If you want to see what it is as it approaches. This one, it's easy enough to take a look at. You're going to see when we build up to this. So here, without evaluating at 3, if I take a look at what's going on with the left, as x approaches 3, coming from the left side, 2.9, 2.99, 2.999, we're approaching what number? Well, as it's coming from the right, starting off with larger values, getting smaller and smaller down to 3, 12.5, 12.050, 12.005. Once again, it looks like we're approaching 12. So, and easy enough as far as we can always just say, right around that number, I can just take the average, those two numbers, 11.995 plus 12.005, divided by 2. I get that answer of 12. In this particular case, I can just say, okay, when x equals 3, what do I get? Right, when x equals 3, 5 times 3 is 15, minus 3 is equal to 12. But that's not what a limit is. A limit is not what is that value. The limit is what are we approaching. You'll see why this makes sense or why I'm saying all this as we go along. So, question?
Oh, no, I.
Okay, so what is this a graph of? Parabola? Yeah, just a straight line, folks. All right? 5x minus 3 has a y-intercept of -3. Slope. So this is what our graph is, and limit as x approaches 3. So as I, from the right or from the left, I'm saying that on that graph, I'm approaching a value of 12. Sure enough, to take a look at 3, and if this was drawn a little bit better to scale, right, we can see we'd be close to that point of 12. All right? What if we had something like this? We want to find the limit of this rational function where x is equal to 0. And that last one, I pretty much could have just said, okay, hey, when x is equal to 3, I come up with the value of 12. Can I do that here? Why not? Because I asked that. Why can't I do that here? What happens when x is equal to 0? What do I have in the denominator? I have 0 in the denominator. Hmm? 0 over 0 is not 1. I'm dividing by 0, which is an undefined operation. All right? When x equals 0, I'm going to have the square root of 9 minus 3. Folks, 0 over 0, do not ever put that down. It's not equal to 1. So, I'm going to have to go ahead and evaluate around it. What's going on with the left? What's going on from the right? So looking at when x equals a negative 0.01, what do we get? All right. 5.998. What about negative 0.001? 5 point what? All right. Negative 0.0001. And we're trying to find out what's going on with 0. What about 0.0001? Four zeros and a 2. All right, so 6.0002. Next one. So, what do we have here? What is my limit of this rational function as x approaches 0? Why 6? As Mario said, we just take that average there. The guys surrounding my, at x equals 0, that 5.9998 plus that 6.00002 divided by 2 is going to give us a value of 6. What does this look like? Did you guys graph it? What's that? What did we get?
It's like a normal,
I'm sorry?
it's like a normal square root, right?
Absolutely. It's like our square root function, just with a translation here. Right? Again, you can know that x equaling 2 is not in our, is it x equals 2? X equals 3, or x equals 0, excuse me. It's not in our domain. We can see when we take a look at this, what is my graph approaching? What is f of x approaching as x equals 0? Well, here I can see it approaching. Oh, don't do that. You can see it approaching a particular value, and at the same time, coming from the left to right, it's approaching that same value. It does not mean anything at all if that value exists, or we're not trying to find out what is f of c. We're not trying to find out what is that f of x. We're just trying to find out where my graph is approaching. And you can see x equals 0, not part of my domain. I actually have a void there. So it's all about where is my graph, where is my function, what is it approaching, not what is that value. A lot of times those are the same thing. The value is the same thing as what I'm approaching, but that's not always the case. Here, we want to evaluate the limit as x approaches 2 of this rational function. Can I use x equals 2 here? Again, I'd be dividing by 0. So, starting off with evaluating at 1.9.
So basically, it doesn't matter if the point exists or not, but it's what the value would be if it did exist at that point, if that point was in the domain.
You see. Yes, for the most part.
Okay.
And you'll see why I say for the most part. So when x equals 1.9, folks, what do we get?
5.61.
All right. 1.99. So far, Michael's the one who can do this one. That's fine. And we'll skip the 2, go to that 2.001. I'm sorry? 0401. And then for our 2.1. So again, I'm not really looking at what is that value when x equals 2. I'm just looking to see how my function behaves as it gets closer and closer to 2. So as we look as it comes from the left, it goes 5.61, 5.96, 5.996. Coming from the right side, 6.41, 6.04, 6.004. Hopefully it's clear to see, as x is approaching 2, where is my function going? Absolutely. Once again, we can take that 5.996 plus a 6.004, add it, giving us 12, dividing by 2 for the average, giving us a value of 6. What's this one look like?
Parabola.
Why a parabola?
Well, I graphed it because it's over x, isn't it? It's an x to the bottom. Does that happen there?
Right. If I take a look, we said I have x cubed on top of an x. It pretty much becomes a x squared function, so it's a parabola, more or less a parabola. with a point or two taken on out. So, again, it does not matter whatsoever if that point exists. It's where is my graph going? Where is my function approaching? We could take a look at the functions instead and graph of them to determine whether or not or what my particular limit is. What type of function do I have? What type of graph do I have? Piecewise function, absolutely. So, how do I graph this piecewise function? By the name of it, it has pieces, right? So how do I graph this first part right here? F of x equals 2, where x is not equal to 3. What is that a graph of? What type? Diagonal, horizontal, vertical?
Horizontal.
Horizontal, absolutely. So a horizontal line, which is undefined at 3. But is this graph defined at x equals 3? It's defined at 0. Right? That's my piecewise function. When x is not equal to 3, it's a graph of f of x equals 2, or y equals 2, right? When x is equal to 3, it has a y value of 0. Yes?
I'm confused how you put the open dot on 3, 2.
It's an open dot.
It's an open dot.
No, I understand that. I don't understand why you put it.
Because x not equal to 3.
X is only going to equal 3. F of x is only equal 2 for all values of x other than 3. When x equals 3, closed dot goes right there to 0. What is the limit as x approaches 3? 0 or some other number. The limit as f of x approaches 3 is equal to 2. What is the value of f of 3? In other words, what is the value of f of x when x equals 3? It's 0, right? When x equals 3, my graph, my f of x is equal to 0. However, it doesn't ask us what is that value. It says, as I'm coming from the left, without even looking at this, just look at it from the left. As I'm coming from the left, and it looks like at x equals 3, I'll have what value? 2. Then it says, okay, now let's take a look at coming from the right-hand side. So as I travel on down here, as I get closer and closer to 3, it looks like my f of x is going to equal, it's still going to equal that same number, that 2, right? Even though that's not the case, at point 2, at x equals, excuse me, I keep on saying 2, at x equals 3, my graph has a value of 0. But the limit and what the value equals at that point are not the same things, or not always the same things. So in this case, my f of 3 is equal to 2. However, my f of 3 is equal to 0. But my limit is just equal to 2. Yes? I have another piecewise, f of x equaling 2x plus 1 for x less than 4 and x squared minus 7. X squared minus 7 when x is greater than 4. So how do I do this? I want to graph both of them, right? So what's that first line? What's that first f of x equals 2x plus 1?
That'd be diagonal line.
Yes, no? That's a y-intercept of 1 and the slope. So up to 1. But what do I do?
All the ones equal.
Exactly. So we said this is where Well, this is where x is strictly less than 4, right? So I have to throw off everything greater than or equal to 4. So 1, 2, 3, 4. Right over here, what do I have? A closed or open circle? That's that first part, 2x plus 1. What about that x squared minus 7? What do we have there? In the list? Parabola.
Parabola.
Vertex where?
-7.
0, -7. So if I was to draw this graph, right, we'd have something like that, right? However, we only want what? John? What do we want? Absolutely, everything greater than 4. So right, we have something like this. Right? This is part of my parabola. Right? Not a straight line, it still has a little hook to it.
So it's attached to the red line?
That's what a piecewise function is, right? Piecewise function, if you remember the parabola, right, it was, that's my parabola, but it only starts where? It starts where, not right at 4, it starts right after 4 because it's strictly greater than. It's not greater than or equal to, so I can't close up that circle. I still have to keep that open circle. Is this function defined at x equals 4? Is this graph defined at x equals 4? Because here I say when x is less than 4, I have 2x plus 1. When x is greater than 4, x squared minus 7. Both of them strictly greater than and less than. None of them are equal. So this is what we get. So the limit of f of x as x approaches 4. If I look at my red line, as it gets closer and closer to 4, even though it's not defined, it looks like it's what value? Two x plus 1 when x equals 4. So it looks like, right? This right up here is 9. Right. Also, when I look at the black part, right, the parabola part, coming from the right-hand side, as I get closer and closer to the value of x equals 4, once again, even though it's not defined there, it's not defined at x equals 4, it tells me I'm approaching a value of, well, in this case, 16 minus 7, 9. Again, there is no, when x equals 4, I have f of x equals 9. When x equals 4, it's undefined. But the limit does exist. It is actually approaching that 9 if I did not know any other information. Yes? No? What about this? Here we have the absolute value of x over x. As I'm coming from the left, f of x, as I'm coming from the left, as x gets closer and closer to 0, what am I approaching? What value? Negative 1. As we're coming from the right, as x gets closer and closer to 0, we're approaching what? 1. So what is the limit of f of x as x approaches 0? What? as Mario and Adriana said, what is the definition of a limit? Absolutely, a unique number. Not plural, unique numbers or anything like that, but a unique number. So in this case, from the right-hand side, I'm approaching 1. From the left-hand side, I'm approaching -1. Does not exist. We have a key hint too that says limits itself. So again, by definition of what a limit is, it's not approaching a unique number. In this case, I have two separate numbers that it's approaching from the left and right, so therefore there is no limit. Here we have the graph of f of x equals 1 over x squared. Are they approaching the same number here? Going from the left and right, they definitely are approaching the same place, aren't they? They don't have to touch.
I mean, you don't know, I guess. You do. Is there like a difference for each?
No. As x approaches 0, what's the definition again of a limit? Unique what? Unique number. So what is my unique number? What are they approaching? As x is closer and closer to 0. What is infinity?
Oh, I was looking at them.
Yeah, it's not.
They're going up. That's where infinity is.
Oh,
What's that? So as x is closer and closer to 0, where is f of x going?
infinity.
So why do I not have a limit then?
Yeah, that's more than one number.
It's not that you want numbers.
As Mario said, infinity is not a number, right? And if you think of a very, very large number, can you come up with a number higher than that? So in this case, since my graph, f of x, as x approaches 0, is approaching infinity, increasing without bounds, once again, no limit. By the definition, it's not approaching a unique number. Over here, we have the sine of 1 over x. I want to look at the limit as x approaches 0. So, when x equals a negative 2 over pi, what do we get? You guys forgot your unit circle, you do have calculators, right? What is 1 over a negative 2 over pi? What is this?
Oh, wait.
1 over a negative 2 over pi. A negative pi half. So actually, negative pi half has a sign value of R. -1. For those of you, again, if you forgot that unit circle, that's exactly what it is. Negative 2 over 3 pi. That gives me a sign of a negative 3 pi halves. Negative 2 over 5 pi. Mario's the only one who can do this, folks. So we'll let Mario take a break from now. So, what about 0? Sorry?
Yeah, don't always skip back to the versus 0.
Yeah, it's always infinity.
We can't use 0, why not?
I don't know.
You fine?
It's over the bottom.
Absolutely. Sine of 1 over x, I can't let x equals 0, then I'm dividing by 0. So what about 2 over 5 pi? 2 over 3 pi? and 2 over pi.
Right.
So what is the limit as x approaches 0? Or in particular, since we're still talking about limits at 2. That's a key thing here. But here you can see, as I get closer and closer to 0, I mean, I can keep on choosing smaller numbers, smaller numbers, smaller numbers. Negative 2 over 7 pi, negative 2 over 20 pi, negative 2 over 100 pi. It's just going to keep on oscillating between that negative 1 and 1 without any stop. So if it oscillates, such as this, no limit. Because again, I don't have any particular number that it is approaching. There is no f of x. There is no L that my f of x is approaching. It's oscillating between 2 points. So if we summarize these, limits that fail to exist, well, if f of x approaches a different number from what? From what? You guys are overthinking. Thank you, Michael. So if it's a different number from the left side of C, then it approaches from the right side, right? Just as we had that absolute value of x over x, we had one approaching that positive 1 and one approaching a negative 1. Also, when we had that 1 over x squared, when my function increases or decreases without bounds as x approaches c. So in other words, right, if it's approaching infinity or negative infinity, there is no number. And lastly, when we look at that sine of 1 over x, if the function f of x oscillates between two fixed numbers as x approaches. If any one of these occur, there is no limit. Otherwise, try to find that particular limit. Questions?